In this video, we're going to talk about finding the x-intercepts of this function, which is a rational function. It's a polynomial divided by a polynomial. So in general, when you want to find the x-intercepts of a function, what you would do is replace f of x or y, if it's y here, by 0 and then solve for x. So that's exactly what I'm going to do. In place of f of x, I'm going to put 0, and then that's going to lead to this equation. And what I would do is what I need to do is solve this equation, and then the solutions of this equation will be the x-intercepts of this function here. So in this function, what I've got is a fraction, right? It's a rational expression, a fraction basically. And what I want to do is to get the LCD. In this case, there's only one fraction, so the LCD, or least common denominator, is just going to be 3x minus 2. And so what I would do then is just multiply both sides by the LCD. Of course, if you had a lot of different fractions in there being added and subtracted together, you'd have to do a lot more work to find the LCD. But this one, there's just one single fraction, so that's the LCD. So what I'm going to do is to take and multiply both sides by the LCD. And what that should do is clear out all the fractions and lead to a simpler equation. There's only one problem in doing that, and that's this. If I solve this equation and I get a solution down here at the end and it makes the LCD equal to 0, then that is not really a solution of the equation, because this step is only justified if 3x minus 2 is not equal to 0. So in the end, I'm going to have some checking to do to make sure that doesn't happen, but we'll worry about that in just a minute. So okay, so over here on the left hand side, I've got 3x minus 2 times 0. That's just going to be 0, right? Because anything times 0 is 0. Over here on the right hand side, I have these factors which cancel, and so that leaves me with x squared minus 4x minus 5. So I multiplied through by the LCD, and it cleared out the fractions and led to a simpler equation. This is just a quadratic equation that I can solve by factoring. But the price you pay for that is that you have to check your solutions that you get and make sure that they don't make the LCD equal to 0. Okay, so like I said, this is a quadratic equation and it can be factored. Okay, so this thing factors to x minus 5 times x plus 1. And then what I would take, I've got these two factors and they multiply together to give me 0. So that means either x minus 5 has to be 0 or x plus 1 has to be 0. So I take each one of those factors and set them equal to 0. And so here I would add 5 to both sides. So I get x equals 5. Here I would subtract 1 from both sides and get negative 1. So these are the possible solutions of my equation. Like I said, the price you pay for getting rid of the fractions is that sometimes doing that, multiplying both sides by an expression that has a variable in it, will introduce solutions that aren't really solutions. So what I've got to do is go back and check each of these to make sure that they don't make the LCD equal to 0. So how I would do that, the check, is just take the solution and plug it back into x, into the LCD. So if I do that with 5, I get 3 minus 2. 15 minus 2 is 13. So that one's okay. So 5 is an okay solution. and then checking 1. If I take and put a -1 back in, I get -3, -2, it's -5. So that's okay. And here, the check, you're just trying to make sure that you don't get 0 when you do that, right? If you get 0 here, then what you would have to do is throw the solution out. But here, both of these are okay, so the two x-intercepts of this function are 5 and -1. And just taking a look, right, if I take and I graph this guy out, a good site to do that is desmos.com. It's free, and you can just type your expression in here, f of x equals x squared minus 4x minus 5 divided by 3x minus 2. And so that's the graph of that function, and we can see here, right, here's one place where it crosses the x-axis, that's at 5, just like we had, and then here it crosses also at -1. So that's just another confirmation that our solution was correct.